So back in the good old days, every Saturday you get your newspaper, you read it from front to back, article to article, but when you got to the end, it was the end. Now what we see happening with the technological revolution is that you open your web browser, you go on CNN, you read an article, and when you finish, there's conveniently 6 more articles that are completely based off what you're interested in, and you're destined to click one. Now you click that one, you read the article, and now there's conveniently 6 more to read from. And this kind of grabs at our desperation for instant gratification and our pursuit for instant gratification. Now what we notice is there's no stopping cue, right? So with the newspaper, you get to the end and you had to stop. That was your cue to end. But what we see these days with any type of multimedia, we see with news, we see with Instagram, your constant stream of information, is that there's never a stopping cue. And what the stopping cue does is it increases the level of dopamine in our brain. Dopamine is what promotes excitement, happiness, joy in our brain. And when these levels are higher, we want to keep going through that stream because we want to feel happy. And so researchers wanted to be able to track these dopamine levels in our brain. And so they had to take a look at the neurons and how our neurons interact when there's high levels of dopamine. The only problem is, in our brain, it's very invasive if we want to be able to track these neurons. So they had to find a way on a very small scale to be able to track the dopamine levels in our brain. And so what they did was they got a carbon nanotube, which is a nanomaterial, and they paired it with a polymer to make a nanosensor. And so what happens is the polymer reacts with the dopamine in the brain, and when the polymer is in contact with the carbon nanotube changes in fluorescence, and researchers can track that. And now what's really interesting is what the researchers found was with different amounts of stimuli or different levels of dopamine, different neurons reacted differently. And this kind of paints a picture that with different levels of dopamine, we may react differently. But what they realized was this goes beyond just dopamine, but with any chemical in our brain. And so they were able to realize that by being able to track dopamine, they could make the parallels to any other chemical, any other drug that's in our brain. So for example, when trying to come up with drugs for Parkinson's or schizophrenia that are as a result of imbalances of chemicals in our brain, they can now create more effective drugs that may react in more appropriate ways because of these carbon nanotubes and carbon nanosensors. And so the kind of big picture is, but because of these nanosensors, our ability to track the ways that our neurons interact is so much more enhanced to create more effective drugs and treatment systems to deal with these brain-oriented illnesses.